Okay, we are going to talk about giant covalent structures or giant covalent compounds. Okay, we said giant covalent structures and not compounds because one of the most important ones is made of only one kind of atom, so we cannot talk about compound. Yes, the giant covalent structures are atoms that are bound together by covalent bond. Yes, but not forming only discrete molecules. Discrete means small molecules, but big giant structures where you can see, for example, in the graphite here, okay, in the graphite here, you're going to see that we have layers of carbon atoms bonded together. Actually, what each of these circles that you see here is a carbon atom. So you have carbon attached to carbon, 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 and so on. And then, exactly, they are going to form some shape like this, like the, like a ¿cómo se dice? Beehive? No. And honeycomb. Okay? They look like that. So, what are the properties of this? Well, let's analyze how the elements are bound and what happens with the electrons and all that. So, if you see here, yes, if you see, let's say this carbon here we have a carbon, another carbon, another carbon, another carbon. And this goes on and on and on. Yes? So let's analyze what happens in the carbon, in each carbon that is bonded here. And this is, I'm trying to represent this one here. Okay? So you have an idea. So what happens here? This carbon atom is attached to 1, 2, and 3. Do you see it? So this carbon here is attached to this one, and this one. I'm going to put it in color so you can see it in color. So this carbon here is attached to this one in the front, this one, and this one. Yes? You see it here. This carbon here is also attached to this one, and this one. So every single atom is attached to 3 things. Now look at the periodic table and tell me how many electrons carbon has in the last level.
Who's the one in the corner?
It has 4, yes? So if it has 4 atoms and is bonded by a single covalent bond to 3, what happened with the extra electron? Well, the extra electron is going to be floating around in between those layers. And that gives the graphite certain properties that we know that it has. For example, graphite conducts the electricity, and you're going to see where can I find graphite? Your pencil. Yes, the graphite in your pencil conducts electricity. Okay, so don't try to make a thing about it. Okay, so you have a layer of electrons, free electrons here in the middle of the 2 layers of the carbon. That makes also the graphite able to write, because when you pass this layer of carbons on your paper, some of these layers are going to stay in the paper because the layers in the surface are going to slide over each other because those free electrons. That allows also the graphite to be a good lubricant. Because of those free electrons, they can slide over each other and they can act like a lubricant, with the advantage of not getting rotten like some lubricants. When you put some oil to lubricate, including the car, okay, we can use, you have to change the oil from the car every now and then because it gets bad, yes? Well, in this case, we don't use graphite in the cars, but in some things like locks, for example, in the doors, if it's stuck and the key doesn't work properly, you can put a little bit of a powder, no powder, like powder of graphite. They sell in Home Depot, for example, they sell like a small cone, like looks like a cone that they use for the toothpaste, and you squish it, and it's going to make like a like a powder of graphite inside the lock, and it's going to make the key work better. Okay?
So
now,
why don't they use it in cars?
Because you need a lot, and because it might produce another things that we don't want, like abrasion. Okay? Now, look at the other two structures that we have here. The second structure that we have is called diamond. And we are going to, the regular diamond. And you're going to say, oh, it's made of carbon, so can we burn a diamond? Yes, you can. Yes, you can. Actually, in one of the videos that I have and that I recommended to you, the waters video, there is one of them that they burn a diamond on
I'm
site.
just gonna be mad when I get home, like get my stepmom.
But there are some diamonds that are not. There are some diamonds that are not. They don't have a high value because they have like flaws inside.
Yeah.
Okay, so those are the ones that they buy. They burn actually. But which is the structure? The structure is a carbon attached to another carbon at the top, and then 3 carbons at the bottom. Okay, forming the same angle, the tetrahedral structure. Yes, do you remember the tetrahedral structure for the methane? But instead of carbon attached to hydrogen, 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 and hydrogen, it's going to be carbon, carbon, carbon. And this carbon is going to be the same thing. It's going to be attached to one carbon, another carbon, another carbon. So we are going to have this one attached to this one, which is attached to this one, to this one, to this one, and then this one is attached to another 4 atoms. So in general, the atom of carbon now is attached to 4 other atoms of carbon. No free electron, no free electrons. Okay, and they are in a certain distance all together, so they form what we call a crystal. Yes, and that crystal is super, super hard. Why is that? Because the carbon is attached to 4 covalent bonds to a different thing. Good? Now, which is the difference between this one and this one here? Well, this is silicon. Yes? And the red ones, these ones are silicon, and these are oxygens. But basically, it's the same structure. The only thing is that there is only 1 oxygen in between 2 silicons. It's like a bridge with oxygens. You are not going to be asked to draw these structures, but you need to know how to recognize them. So you need to know how to recognize them.
Why is it dioxide?
Give me 1 second.